Hi, welcome to the video tutorial brought to you by programmingfree.com. In my previous tutorial, I explained how to secure a Spring MVC application using Spring Security and Spring JDBC. I created a sample project with authentication and authorization to demonstrate the same. In this tutorial, I'm going to explain how to use Spring Data JPA along with Spring Security instead of Spring JDBC. At this point, if you do not know or if you are new to Spring Data JPA or even JPA, you might probably think, why should you go for Spring Data JPA when you can simply use Spring JDBC to secure the application with the user details stored in a database? I'll explain this. Java Persistence API, JPA. What is this? Unlike writing a plain DAO that consists of plain JDBC code everywhere full of prepared statements and SQL connections, etc., we just map the original fields in the database table to Java classes called entities, provide SQL queries, and let the Persistence API handle the connections, query execution, etc., without writing much boilerplate code. JPA is just a specification, and to use it you must use a provider of this specification such as Hibernate. In other words, consider JPA as a set of interfaces, and you need an implementation of these interfaces to actually use it, which we call a provider. Now you know that JPA is a specification and Hibernate is an implementation of JPA specification. So what is Spring Data JPA? It is not an implementation or a provider of JPA, but it sits on top of JPA and uses the provider of your choice to generate queries and to do all that the JPA specification is meant to do. It provides a stronger design, which is also easy for anyone to implement, and the best part is you're not tied to any JPA provider. For instance, if you're using Hibernate directly in your project and if it has a bug, your development will stall. But if you use Spring Data JPA and use Hibernate as the provider for Spring Data JPA, you can switch anytime to any other provider like Eclipse Link or ObjectDB or any other provider with very minimal level of code change. Having said all that, if you are working on a web application that uses Spring Framework and it deals with databases, then Spring Data JPA is the way to go. Let's get started now. The first thing to do is to set up users table and user roles table in MySQL Server. Make sure the password field can accommodate 60 characters because we'll be using bcrypt password encoder to encode the passwords, and that will be generating a 60 character output all the time. Also, Spring Security expects username, password, and enabled field for authentication and the role name for authorization. So you must have them all in the database. You can use the same queries that I have used for practice, and you can find the download link for this project below. Note that I've used user ID as foreign key in the user roles table because if I use username as foreign key, I won't be able to change that in the future even if I want to. So it's always a best practice to use user ID as foreign key instead of username. Now download the project from the link given below and import it as a Maven project in Eclipse. I have used Maven for this project setup, and let's have a look at pom.xml file. This application uses a MySQL server, so we have the MySQL connector in place as a dependency. It also uses Spring Boot, and to leverage Spring Boot, you need to set the Spring Boot starter parent project as your Maven parent and put some dependencies in your POM. We've got Spring Boot starter web for setting up and initializing Spring MVC, Spring Boot starter JPA for setting up and initializing Spring Data JPA with Hibernate as provider, and Spring Boot Starter Security for setting up and initializing Spring Boot Security. Before I start explaining the implementation, I'd like to show the application itself for a better understanding. Initially, when the application is loaded at the root URL, we show a welcome page that is accessible by everyone. The welcome page has a link to the greeting page which is protected, and hence the user will be redirected to the login page if he or she is not authenticated. Also, the greeting page is authorized to be shown to users who play the admin role, and therefore a non-admin user will be redirected to the access denied page. To access the greeting page, any user must be authenticated and also play an admin role. You can also see that the user is thrown an error message for invalid credentials. Now let's go ahead and have a look at the implementation. Inside source main web app, I've got the JSP files. 403.jsp for access denied, hello.jsp for greeting, home.jsp for welcome page, and login.jsp for the login page. Inside main Java, we have three packages: config, domain, and security. Config contains all the configuration classes required for this application. Domain package contains all the database related classes, and security contains all the security related classes. You can also see an application.properties file at the same location as that of the pm.xml file. Application.properties file is where you put the database related details, and if you're using this application, you got to change all this and replace it with your credentials. We are using Spring Boot, and we have a class called application annotated with @Spring Boot application annotation. This tells Spring Boot to start adding beans based on class path settings, and also to look for other components, configurations, and services in the same package. The main method uses Spring Boot's Spring application.runoff method to launch the application. If you had noticed, we are not using any web.xml, or you don't see a dispatcher servlet configuration. It's because Spring Boot configures everything for us. We've used @enable JPA repositories annotation to enable JPA repositories in the application, and domain is the package where Spring Boot will look for repository definitions and classes. We've also used entity scan annotation that tells Spring Boot to look for entity classes in the application. An entity class is a class that represents a table in our database. We need both enable JPA repositories and entity scan annotation to be present in the root configuration class for Spring Data JPA to work in our application. We have a mvc-config.java class for MVC configuration. This web application is based on Spring MVC. So to expose the JSP pages, we need to set up view controllers. This is done by overriding the add-view-controllers method in the web MVC configurer adapter class. Basically, we are telling the system which JSP to load when an URI is hit. We also have a web security config.java class that has all details related to security, but we'll come back to this later. Let's have a look at the entity classes now. Here you have a user class annotated with entity, indicating that it is a JPA entity. We also have table annotation with a table name to which the entity will be mapped to. In case the table name and the name of the entity class is the same, you can omit table annotation. The user class has 5 attributes: the ID, the username, the password, the email, and the enabled. The user ID property is annotated with @ID so that JPA will recognize it as the object's ID. The ID property is also annotated with @generated value to indicate that the ID should be generated automatically. You can see that the properties are annotated with column annotation. This is not required if the column name in the table is the same as that of the property name in the class. We have two constructors. The default constructor only exists for the sake of JPA. We won't use it directly. The other constructor is the one that we'll use to create instances of user to be used by Spring Security to authenticate. We've got one more entity class, userRoles.java, that represents the user roles table in the database. Spring Security requires data from users and user roles table to authenticate and authorize an user. So we need classes that retrieves data from these two tables, and this is done by defining repositories in Spring Data JPA. In our application, we have two repository interfaces defined, the user repository and the user roles repository. Spring Data JPA has the ability to create repository implementations automatically at runtime from a repository interface. Traditionally, we used to write DAO classes with SQL connections, queries, etc. But here, everything is done by Spring Data JPA. Now let's see how it works. We have defined a user repository interface that extends the CRUD repository interface. The type of entity and ID that it works with, user and long, are specified in the generic parameters on CRUD repository. By extending CRUD repository, user repository inherits several methods for working with user persistence, including methods for saving, deleting, and finding user entities. Spring Data JPA also allows you to define other query methods by simply declaring their method signature. In the case of user repository, we have defined findByUsername method, which takes username as a parameter and returns all the matching rows based on the username parameter. You don't even have to write an implementation of this method, but just with this definition, Spring Data JPA creates an implementation on the fly when you run this application. In case there's a requirement to write your own queries, we can do that too. In this application, we have used user ID as foreign key for the roles table. So in user roles repository, I have written my own query on the find roles by username method just by adding @query annotation to this method. Note that the query is written using JPA query language with the entity names for tables and property names for the column names. There are several other ways to write custom queries. You can learn about it later from Spring documentation if you're interested. Now that we're done with repositories, next step is to create classes required for Spring Security to use the data returned by the user repositories to authenticate users. Spring Security looks for an implementation of user details service interface that loads user-specific data. So we have to write a class that implements user details service and override the one method that this interface has, which is load by username. In this application, we have a custom user details service class that implements user details service, and inside the load user by username method, we have used user repositories find by username method to get the user details specific to the provided username. We also used the user roles repository to get the list of roles associated with the user. Now there is one more thing to learn here. We may have a lot of information inside our user table that we may need to access in our application. But Spring Security does not require all the information that are in the user table, but only a few properties to perform authentication and authorization. So, in order to return only required details to Spring Security, you can write a class that implements UserDetailInterface. UserDetailInterface provides the core user information. Here we have a custom UserDetails class that implements UserDetailsInterface with methods to return a set of authorities, username, password, and few other methods. It already extends the user, so it is a user, and it also has some extra methods that the Spring Security requires. So we have a custom user details class, and what we do now is just return a new object of it created with the user information from the load by username method. Let's go back to the web security config class now. We have set up our custom user details service class already, and now we have to pass this to the authentication manager builder in the web security configuration. We also have to configure the HTTP security to define the pages to be authenticated and authorized, specify the login page name, specify access denied page, etc. In this configuration, we have the greeting page authenticated and authorized, and we have left all other pages unauthenticated. I have also created a password encoder bean that uses Spring's bcrypt password encoder. In the database, I've stored bcrypt encoded passwords and not plain text. So this password encoder tells Spring Security to decrypt the password based on bcrypt algorithm and then process it. Well, that's it. The security implementation is done. Let me quickly show you the login page alone. As you can see, this JSP page simply presents a form that captures the username and password and posts them to /login. As configured, Spring Security provides a filter that intercepts this request and authenticates the user. If the user fails to authenticate, the page is redirected to /login query string error, and the page displays the appropriate error message. Upon successfully signing out, the application is sent to /login query string logout, and the page displays the appropriate success message. Let's go ahead and run the project. Run as Maven build. Provide goals as clean, install, spring-boot: run. Server has started. Let me bring up the application. Localhost: 8080. I'm logging in as a non-admin user initially. I'm redirected to access denied page. Now trying to log in as an admin user and got the greeting message. So that's it, we are done. Hope you all liked this video tutorial, and you can find the download link for the sample project I've explained in this tutorial in the description below. I'll also be writing a step-by-step guide in my blog on the same topic, and I'll update this tutorial with the link once it is done. So stay subscribed and happy coding.